I have a very simple project, a RAG application that I've built just using OpenAI API, and the database I'm using, that is the vector database, is Milvast database, but I'm using the light version. So this project is really simple. We basically have docs here in form of .mds that I'm actually indexing, or basically ingesting all this, like my knowledge base. And then is my main file, which of course, this is a simple project. I have all the logic inside here. I'll run this project just real quick so that I can show you how it works, and then explain to you how you can actually set up tracing of your AI application using LangSmith, which is a tool from LangChain. It's basically in the ecosystem of LangChain. When you're building your AI application, sometimes you might encounter bugs or errors, but then you don't know how to trace them or to know where exactly is my project or application breaking. And aside from that, you might also want to check, like, how many tokens am I using and what's the cost of the tokens that I'm using. That is what we're going to discuss in this video right now. So up here, I'm importing Milvast client from PyMilvast. That is the package that we have from the official Milvast database. And then I'm loading the environments, importing the glob package, OpenAI package, and then we have TQDM. TQDM is basically a package that shows you the progress of whatever process is running on your application, and then JSON will be used. And then now we have LangSmith and LangSmith wrappers. Now for this, I'll explain them later. And then now I'm loading the environment files here, and I'm creating a connection or an instance of my Milvast client, that is Milvast Lite. So Milvast Lite, actually Milvast comes in varieties in 3 versions. One, Milvast Lite, which you can use for development or just small loads for your development. And then we have Milvast standalone, which you can use for a simple project that is in production. And then we have Milvast cluster, which you can deploy on Kubernetes that can scale horizontally. Now for this simple project, I've chosen to use Milvast Lite, and that's why I'm creating a connection to Milvast file here. And then right here, also forget about this one here, I'll explain later. And then I'm initializing a collection, my RAG collection, and then text lines. Basically, this will be responsible for the chunks that I will be generating. And then we have the data there. So right here, what I'm doing is reading the knowledge base. Basically, it's a file. So I'm basically opening the file in read mode. And as file, what I'm doing is trying to have each and every line from that file into text lines array or list here. And then we have traceable here. Now for traceable also, leave it at the moment, I'll explain later. But let's come to this function. Function is to embed text. It's encoding our text files or .mds into vectors. What we are doing is returning OpenAI client .embeddings create, and then my embedding model is text embedding 3 small, and that is it. And then right here, this was just a test. And now here, I just want to find the length of the embeddings and then print the embeddings dimension. That is what we have here. And then the last 10 vectors that we have. Now, right here now, I'm now trying to create my Milvast client has a collection, which is a collection name, which you have here. Which is the collection name? My RAG collection. Then I want to drop it first. And then I'm going to create now that collection. And you have to pass the arguments, that is the collection name, dimensions, like the embedding dimensions. That is, remember it was 1036, 1056 somehow, and then metric IP. These are related to Milvast DB. Now right here, what we are trying to do for each line in the lists or array we have here, text line here, basically that's the chunks, we are going to create embeddings. So you see what we're having here? So what we're doing is looping through that text lines, and then we create embeddings here. Look at that right here. We create the embedding per line, but then we have to wrap it with the TQDM package so that it will show us the progress of what's happening. And then we insert that data, which is now the metadata, or the vector, into our Milvast. And then we have the question, which is my prompt, which I'll be prompting the RAG application, which is how's data stored in Milvast. Then we have now the search method or function of Milvast, which basically will take our question and then give us the relevant chunks or documents from our knowledge base. And then right here, we're just trying to retrieve lines with distances we're trying to find like the search results. Then if you come here, just to skip really quick, we have system prompt here, and then we have the context. The context is basically the relevant chunks that we've retrieved. And then the question, which is how is data stored in Milvus? And then we basically now just hit the LLM with all that. There's role as a system, content, system prompt, and everything. Then I want to stream my response so that every token generated, we automatically get it back to the UI. So that's just like overview of what we've built here. Now let me just run this application really quick. Python, and the main script is main.py, press enter, and then let's see what happens. So it's creating the embeddings. You can see the progress here, which we have achieved by the use of this module here. TQDM is a module in Python that will show you the progress of a process when your app is running. So let's see what we have, and then it will go ask the question, how is data stored in Milvus? So that is almost done. We're at 90, 92, and we are at 100 in a moment. That is done. So I want to show you what exactly happens here. Now you see what we have here is the relevant chunks first, which you get from the search. That is here. This method here. Let me show you the search method here. So this is what it returns, the relevant chunks. So where does Milvus at that? And then that we use it together with the context and our system prompt, which is here, and then we send that as an augmented prompt to our LLMs, and then our LLM has given us back the response, which is data in Milvus is stored in persistent storage as incremental logs. Inserted data, including vector data, that is the response we are getting from the LLM now. Basically, it's a simple RAG application that I was just building so that we can have this demo today. Now, just to take you back to the course that we skipped, that is one here. From LangSmith, import traceable. Why? Because we want to trace our application. This is an AI application, and we want to trace it using a tool from LangChain ecosystem, which is the LangSmith. And since we are in LangChain ecosystem or LangSmith, we want to import a wrapper for OpenAI. So that is why we have from langsmith.wrappers import wrap OpenAI. Remember here we have an API key from OpenAI. So for any request that is being sent to that endpoint or that API key, that it will be traced using this wrap OpenAI, as long as we have this function here. Now, how about traceable? Traceable now, this is like a decorator. We can add it as a decorator to any function where we want it to be traced using LangSmith. For example, at this point, I added the decorator on our embedded text function. So traceable basically telling LangSmith that we want to trace how this code is being executed, or rather, how embedding is happening. How do we set up what we call this tracing? Now you need to go to LangSmith website. Just go to Google and search LangSmith, the first link. Then you need to create an account or log in. So for me at the moment, I have two projects here. So I'll just delete all. Delete that project. Delete. Now when you first log in, this is what you will get. You will get this button here, set up observability. So click on that, and then that will bring you to this new pop-up window or slide-in window. Then first things first, create an API key. Look at that, and then copy that API key. Now in my case, you just copy this and come back to your .env file here. I already have my API key right here. The next thing you want to do is to check what we have here. You have to set also LangSmith tracing is true. Back here, I have LangSmith tracing true. And then we have now LangSmith project. In this case, we have PR elderly and 15. Just copy the name here, Ctrl+C, and then go back to your .env and paste that name. Instead of a Tasa, just paste that name there. That is it. And then you are done. Just a little thing that you need to do. Come to your main, and then now from LangSmith import traceable, and then from LangSmith wrappers import wrap OpenAI. This will basically wrap OpenAI so that LangSmith can trace every call to that Open API key. And then the traceable, like I mentioned, you can pass it as a decorator to any function that you want to trace using LangSmith. So let's see what happens. Now, at the moment, so we have that set up. We can just go back here, and then you see right here it's empty. So I want to run my project again. What I'm going to do is just clear here, and then run it again. Then we want to see what happens on our LangSmith portal. Embedding done, and now let's stream our response here. Fantastic, response streamed. And that is it. Now let's go back to our LangSmith portal here. Let's see what happens. Now you see we have one project right here. Let me just refresh, and then we see the project right there. Fantastic. Now see we have that project here, PR elderly and 15, and then you can see the run count is 75, error rate is 0%, latency for P50 is 0.62 seconds, and then we have another latency which is 6.13 seconds. So what happens? Let me just click on this project so that we can look at detail of what happens. Now you can see the API endpoint was hit 75 times, and whatever we've done has cost us $0. Total tokens $0, and then error rate we have 0%, which means we have no errors in whatever we are trying to run in application. And then if you can see here, we have every code that was made. For example, we have the function called embed text. Remember, embed text was to create the embeddings or vectors. And remember, we for every chunk or every text line in our doc files, that function is being called. So you can see, for example, if I pick randomly, does Milvus support? Let me click on that, and then we see. Now the text is, does Milvus support NAN86 architecture? Milvus cannot be installed on RAN platforms. Your CPU support, your CPU must support one of the following instruction sets to run Milvus, and we have them right there. So this was like the chunk that was created during chunking, and then this function was called to produce these vectors. See the vectors we have here, and we have 1536 vectors. That is the dimension that we are using. Okay, ideally text embedding 003 small gives you 1536 dimensions of embeddings. That is what we have here, and this has been done for every chunk. That's why we see embedded text repeated here again and again, because that function is being called for every chunk or for every line of text. Okay, let's look into something again. Coming on top here, what do we have now? This was now what was sent to OpenAI. Now look at this chat OpenAI function there. So let's see what we have for the chat OpenAI function here. What really happens now? The input is you are an AI assistant. You are able to find answers to the questions from the contextual passage snippets provided. Now this is the human. Now use the following piece of information enclosed in context tags to provide answers to the question enclosed in question tags. And then we have the context opening tag here, and now this context here is basically the relevant chunks that have been returned or retrieved when we did a Milvus search. Let me explain. Right here, let me show you right here. We have a search function, search. So search, which collection are we searching? The collection name, and then the data that we're searching for is the question itself, which we have embedded for it to understand. And then the limit is 3. Basically, we need at least 3 relevant chunks. Then search params here are just like parameters for the search, and the output fields is text. We only want to see the text field, right? And then something else I need to explain is, now this is the context. So we have like the context here is the retrieved chunks. Context number 1 is this one, context number 2 is this, and context number 3 is this. And then now the question in between the question tags. Look at this. The question is, how is data stored in Milvus? If you come back to our code here, where is the question? How is data stored in Milvus? And our augmented prompt is right here. System prompt is here. System prompt is here. Human, you are an AI assistant. You are able to find answers. Then user prompt, use the following. And I've explained that on the LangSmith website. And then the question is here. This is exactly what we are having here. That is system prompt, context, and then the question. And then the output is down here. This is now the output from AI. It has used our context and the question to give us a response which is coherent. Milva stores inserted data, which includes vector data, scalar data, and collection-specific schema in persistent storage on an incremental log. The supported object storage backends for Milvas include MiniIO, AWS S3, Google Cloud GCS, Azure Blobs, Alibaba Cloud, and all that. And you can see this request was successful. Success. Total tokens 0.00 is the cost, 0 tokens, and then type is LLM. So what else can we check here? Metadata, that is just some of the parameters in play, like the project name, tracing is true and all that, and then the traceable method, the traceable, remember that, and that was the run right here. That is all we have. So basically, that is how you can use LangSmith to test your application. If any case we found errors, we could have tested them from here. Also, you can see the time it took the LLM to give us the response. Thank you for watching, guys. See you in the next video. Osego Codes signing out.